Okay. Okay, here we go. Okay, here's what you need to know for the test review. You need to understand constant rate of change. That's just taking this number and subtract it from this number. So, for this I would go 18 minus 24. That's double dash. It's 6. So this is plus 6. I will do it again for this one. Negative 12 minus a negative 18, double dash. That's 6. Okay? That's, in actuality, that's all we're doing. But I've had you look at it and just go, what's the change here? Is it increasing or decreasing? Increasing. By how much? 6. Increasing or decreasing? Increasing by how much? 6. That's one way to do it. Another way to do it is just y over x. So, negative, this is my y, this is my x. Negative 6 over 9. I can reduce that to negative 2 over 3. Okay? I should get the same thing down here, but I'm not going to get the same thing. Y over x. 0 over 12 will be 0. Okay? So, this way is rate of change. This way is direct variation. Both are equal to slope. Okay? So you may have to use rate of change to find it. It may work. Or direct variation may work. In this issue, in this instance, you see direct variation did not work. This one did not work. Okay? But this one did. Plus 6, plus 6. Plus 1, plus 1. I'm sorry. Plus 3, plus 3, plus 3, plus 3. Okay? So, by using the rate of change, I found that my slope was 6 over 3, which is really 2. All right? But I had to use rate of change to find that. This is rate of change. Direct variation is when you go y divided by x. That's when I went 6 divided by 9. Okay? Know how to do both. Know how to do both. Let me repeat it. Know how to do both. One might work and the other one might not. Okay? For this one, this graph, you should be able to look at a graph and look at that line and say, is that line a straight line? If it's a straight line, then it's a linear, then it has a linear relationship. Okay? Period. If it's a straight line, it has a linear relationship. So that's why I can simply put yes. And then once I know yes, it has a linear relationship, I have to say, what is the constant rate of change? Or what is the slope? Slope. Okay? Slope. Slope. And I know I find a point here and a point here. I need to figure out how can I get from this point to this point. Well, to get from this point to this point, I needed to go down. 1, 2, 3, 4. So that's a negative 4. Then I need to go over in the positive direction. 1, 2, 3. So negative 4 over 3 is my M. If you can count the lines, don't rush. Count the lines down and over. It's not always going to go to the origin. Okay? You just bring it down till you get to where that point lines up and then go over. Describe what slope is. Slope is rise over run. It's the constant rate of change. Okay? It's the steepness of a line. All these things work for describing slope. What is the slope formula? Slope formula is m equals y2 minus y1 over x2 minus x1. This is slope formula. Okay? Slope formula. Got that? Let's keep running through. If I need to find the slope of a line, I probably should use slope formula. Because it equals m equals y2 minus y1 over x2 minus x1. I must label. It's so important to label. x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. And then I'm just plugging them in. I'm just plugging them in. y2 for number 5 is 5. y1 is 19. So 5 minus 9m equals 5 minus 19 over negative 3 minus 4. 5 minus 19 over negative 3 minus 4. This is going to be a negative 14. This is going to be a negative 7. I know that a negative over a negative is a positive, and I also can reduce this. 14 divided by 7 is 2. Let's do this one. M equals 8 minus 0 over 0 minus 4. 8 over negative 4. A positive over a negative is a negative. I can reduce this to negative 2. Let's do this one. M equals negative 4 minus a negative 12 over negative 2 minus a negative 6. Two negatives make a positive. Here we go. Positive 12, negative 4. My answer is going to be positive, and that's going to be 8. Positive 6 and a negative 2. My answer is going to be positive, and that's going to be 4. This equals positive 2. Once again, I wasn't zoomed out enough. All right? I just did those 3. This one, this after the game. After the game, after game 1, so they told me something. After something happened, this happened. So this was dependent on this. So game 1, 14 points, 114. After game 1, Javaria scored 14 points in the basketball game. After game 5, Javaria had scored a total of 82 points. If Javaria's score is linear, what is the average points per game? Hint, think slow. Write a solution sentence. Okay, so I have to have a sentence. So let's go. So game 1, 14 points. Game 5, 82 points. Okay, I picked those out. Then I'm going to use, guess what? Slope formula. Y2, let's label first. X1, Y1, X2, Y2. So 82 minus 14 over 5 minus 1. 82 minus 14. 68 over 4. I can reduce that to 17. So Slope is 17. Another way, I know that the top part is points for every game. So, Javaria scored 17 points per game. Period. That was it. 9. Explain how you know when a linear equation is also a direct variation. So something can be a linear equation without having that direct variation. So how do I know that it's also direct variation? First thing, it goes through the origin. Zero comma zero. It's proportional. Meaning that every time I do y over x, I should get the same number. Every time I do y divided by x, I should get the same number. I should get a m. Okay? Those are the two main things. You know that if it goes through 0, 0, and it's proportional, y over x will give me a constant number every time. Y over x equals m for each x and y value. Okay? So they got to go together. You can't just pick out what you want. It's the x that goes with the y. Down here, they want us to determine if it's a direct variation. Let's do it. X over y equals m, which is also equal to direct variation. All I'm doing is 19 over 8, because this is my y and this is my x. 21 over 9. 23 over 10. 25 over 11. Calculator. 19 divided by 8. 2.375. 21 divided by 9. Wow, that's a lot of 3s, so I'm going to write that as 2.3 repeating. 23 divided by 10. I don't even need a calculator for that. 23. If I divide by 10, my decimal was there, I'll bring it right here. So 2.3. And 25 divided by 11. 2.27272. It looks like it's repeating. 2.27 repeating. Are these all the same? Did I get the same thing each time? No. It is not a direct variation. Okay? Let's try this next one down here. 10 divided by 2. So let me divide my work up so you know that's that. 10 divided by 2. 20 divided by 4. 30 divided by 6. 40 divided by 8. 10 divided by 2 is 5. 20 divided by 4 is 5. 30 divided by 6 is 5. 40 divided by 8 is 5. Are they all the same? Yes, they are. So yes, it is a direct variation, period. The constant of variation is 5. Okay? If you have yes and 5, I'm happy. Okay? Yes, 5. No. Show me this work. That's good enough. All right? We're doing some more direct variation, but we're doing proportions. All you got to do, if y equals 16 when x is 4, find y when x is 3. If y, so I know, first off, I know I'm writing it y over x equals m. Because it's telling me y varies directly. Whenever you see varies directly, that's direct variation, which you know equals y over x. So let's do it. 16 over 4 equals, I don't know what y is, over 3. Okay? We're going to cross multiply. And I could really reduce, to be honest, but we're not going to get into that. Okay? Cross multiply. 3 times 16. 48 equals 4y. Divide by 4 on both sides. 12 equals y. There we go. That's my answer. Same thing here. 15 over negative 3 equals x. Find x when y is 45. So you got to make sure you read, because this time they want me to find x. So find x. You got to make sure you read. Negative 3 times 45. So I got 15x equals negative 135. Divide by 15 on both sides. X equals negative 9. Okay? Same thing here. Width of a rectangle varies directly with length. So width is my y, x is my length. If the width is 5 and the length is 12, so that's 5 over 12.5. What would the area of the rectangle be with the length of 15 inches? So, W is what I don't know, and the length is 15 inches. Okay, down here I cross multiplied. I had 75 equals 12.5 W. I divided both sides by 12.5. I got 6 W. Here they asked me to state the slope and the y-intercept of each linear equation, then graph the function. Here, this is written in slope-intercept form. Slope-intercept form. Y equals mx plus b, where I know what m stands for the slope and b is the y-intercept. Okay? So I look at my first problem. Y equals mx plus b, so negative 2 must be my slope, so negative 2 over 1 is my slope. 3 is my y-intercept, so I write that as 0, 3. I start at the y-intercept because it's a great starting point. 0. I start at the origin, 0, so I don't go anywhere. Up 3. 1, 2, 3.